and welcome to AfroCoders Hub. Today we will explore the fundamental concepts of object-oriented programming, or OOP, using Java and IntelliJ IDEA. So let's get started. Object-oriented programming, or OOP, is a programming paradigm centered around the concept of objects. These objects can contain both data and methods that operate on that data. OOP provides a structured way to approach programming by organizing software designs around these objects, which can represent real-world entities or abstract concepts. In this video, we will explore what objects and classes are, and then break down the four fundamental concepts of OOP. First, let's understand what an object and a class are in Java. A class is a blueprint or a template for creating an object. It defines the properties and behaviors that the object created for the class will have. Think of a class as a blueprint for a house. It outlines what the house should look like, what features it will have, but it's not an actual house by itself. And an object is an instance of a class. It is a concrete entity that has states and behavior defined by its class. Using the house analogy, and the object would be an actual house built from the blueprint. It has specific values for its attributes like color, size, and number of rooms. So let's take a look at a simple example in Java to illustrate classes and objects. First, let's look at the class definition, which we have over here. Here we have a class named car, and in our car class we have two fields, the string color and the string model. This field will store the color of the car, and the model one will store the model of the car. We also have a method named display details over here. The method prints out the model and the color of the car. Notice how it uses the field model and color to display the details. Next, let's look at the main class, which contains the main method. The main method is the entry point of any Java application. Let's break it down step by step. First, we create an instance of a car class, which is an object. So here, my car is an object of the car class. Create an object involves calling the constructor of the class using the new keyword. Next, we set the field color and model for our car object. We assign the value red and the color field and Toyota to the model field of the my car object. Finally, we call the display detail model to print out the details of the car. So let's go ahead and look at what our output will be. So we get this output because the display detail method prints out the value of the model and the car field of the my car object, which are set to Toyota, red, respectively. So next up we'll see the fundamental concepts of OOP, which are encapsulation, inheritance, polymorphism, and abstraction. So encapsulation involves bundling the data and method that operates on the data into a single unit called a class. It restricts direct access to some of the object's components, which can help prevent unintended interference and misuse. In this code, over here, the person class encapsulates the name and the age field, providing getter and setter methods to access and modify them. So to look at them in depth, here, so we have a simple Java class called a person that demonstrates the encapsulation. So let's break down the whole code step by step to understand how encapsulation works in this example. First, we have two private variables. So these variables are declared as private, which means they cannot be accessed directly from outside the person's class. This is the essence of encapsulation, hiding the internal state of the object and requiring all interaction to be performed through the methods. So next we have the public getter and setter method for each private variable. These methods provide controller access to the private variables. The get name and get age method allows us to retrieve the value of the age and the name, while the set name and get name methods allows us to modify these values. By using these methods, we can add validation and other logic to the control how the variables are accessed and modified. Next, we'll see what inheritance is. So, inheritance is a mechanism where a new class or subclass inherited attributes and method from an existing class, which is a superclass. So, this promotes code reusability and establishes a nature of hierarchical relationship between classes. So, let's go ahead and see an example. So here we have a Java code that demonstrates inheritance. So let's break it down step by step. We should start with the base class, which is called an animal. It has a method eat. This method prints a simple message indicating that the animal eats food. Then next we define a dog class that extends the animal class. The dog class inherits the eat method from animal, and also it has its own method bark that prints a message indicating that the dog barks. In the main method, we create an instance of the dog class called myDog, which is an object. Then we call the eat method on myDog, which is inherited from the animal class. After that, we call the bark method specific to the dog class. So let's talk about the output of this code. First, let's run it. So when the myDog eats is called, this animal eats food. That's what we have printed over here first. So this shows that the myDog, an instance of the dog class, has access to the eat method inherited from the animal class. And also, when myBark is called, when it's called, it prints the dog barks. This demonstrates that myDog also has access to the bark method defined in the dog class. So this is it for inheritance. Let's go ahead to polymorphism next. So polymorphism allows methods to do different things based on the objects it is acting upon. This can be achieved through method overriding. Some methods names different implementation in subclasses, and method overloading. Some same method name but different parameters. So let's go ahead and see a simple example. So here we have a Java code to demonstrate polymorphism. So let's break it down. Okay. So we have a base class called animals with a method sound or make sound that prints a generic message over here. This animal makes a sound. And let's dive to the next two classes, cut and a cow. That extends from the animal, which we already have seen in the inheritance stage. Okay, which each class overrides the make sound method to provide a specific sound. As you can see over here, like a cat meows and a cat moos. Okay, so in the main method, we use the reference variable f-type animal to refer to different objects, like we have a cat and a cow. Then we call the make sound method for each of them to the appropriate version is executed based on the actual object type. So this will make sense when we run it. Okay, so for the first one we get the cat meows and the cat moves, but let's go ahead and see how this happens. So here my animal is equals to, over here, this line sets my animal to a new cat object. So the my animal dot make sound calls the make sound method of the cat class, which prints the cat meows. For the next method, the my animal is equals to new cow sets animal to a new cow object. Then my animal dot make sound calls the make sound method of the cow class, printing the cow moves. This is it for polymorphism. So next up is abstraction. Abstraction is the concept of hiding complex implementation details and exposing only the essential features of an object. It can be achieved using abstract classes and interfaces in Java. So let's go ahead and see a simple example. So here we have a simple code to demonstrate abstraction. So we define an abstract class called shape with an abstract method draw. An abstract method is a method that is declared within an implementation. The shape class cannot be instantiated directly. So we define two classes called circle and a triangle that extends shape. Each class provides its own implementation of the draw method, as you can see over here and over here. Next up is the main method. In the main method, we use a reference variable f-type shape to refer to the different objects, which are a circle and a rectangle. When we call the draw method, the appropriate version is expected based on the actual object type. Now let's go ahead and see the output. It will make more sense. Okay, so over here, this object sets my shape to a new circle object, and my shape dot draw calls the draw method of the circle class, printing draw a circle. And in the second method call over here, the my shape is equals to new rectangle sets the my shape to a new rectangle object. And the MyShape.draw calls the draw method of the rectangle class, printing, drawing a rectangle. And to wrap it up, we have covered the fundamental concepts of OOP, which are encapsulation, inheritance, polymorphism, and abstraction, using Java and IntelliJ IDE. On the next video, we will focus more on Java, the language. Thank you for watching.